Hi, I'm Mr. Franklin, and today we're going to talk about measurements when it comes to gases. Some of this actually applies across the board and isn't specific to gases per se. Some of the stuff we're going to talk to, but we're going to really be thinking that everything is in the context of a gas. That said, however, we're going to talk about temperature first, because that's one of the measurements we're going to be making, and one of the laws that we're going to be talking about is how temperature affects what happens with the gas. So now, we're all familiar with the first temperature scale, degrees Fahrenheit. That's what we live with. 32 degrees Fahrenheit is when water freezes, 212 is when it boils. Degrees Celsius, we've used that in science classes before. It's what most of our thermometers are. It's what our thermometers are measured in our class. 0 degrees Celsius for when water freezes, 100 degrees Celsius for when water boils. Now, you got to understand that the Fahrenheit scale was created. Basically, they took a tube of mercury, they would measure the temperature, and they had a ruler. And they would segment it in such a way that whatever the ruler measurement was, that's what number they came up with. Okay? When it came to degrees Celsius, what they decided was they defined the temperature scale as 0 was water freezes and 100 was when water boils. Okay? So it's by definition that degrees Celsius is that way. Okay? Well, unfortunately, these are still very relative to water and to what you're measuring. So eventually, Lord Kelvin came up with this system here called Kelvin. Notice it's not degrees Kelvin, it's just Kelvin. And 273 Kelvin is when water freezes, and 373 Kelvin is when water boils. But the Kelvin scale is defined as basically off of this. 0 Kelvin is where absolute zero is where all particle motion stops. Everything stops moving. The electrons stop moving, everything ceases its motion, and this is where we start to enter the fifth state of matter and achieve the bose-einstein condensate. And I've said this before, but if you want to check it out, you can go to the BEC homepage. They're based out of Colorado, and they will show you how that's made if you want to just play around with that and check that out for yourself. So the thing is with gases is we're going to measure things in degrees Celsius, and most of the time we're going to want to convert it to Kelvin, partly for practice, but because really Kelvin is a more authentic way of measuring things. Because we've also defined it in our kinetic molecular theory of gases. We define Kelvin, and we've said that Kelvin is directly proportional to the kinetic energy of an object. Okay? So this tells us something very specific about the particles and how they're moving. So because of that, we're going to want to deal with Kelvin. So we're going to convert from degrees Celsius, because that's what we're going to measure in, but we're going to calculate in Kelvin. So to do that, Kelvin equals degrees Celsius plus 273. It'll be a more accurate 0.15. Okay? So 15 degrees Celsius, let's convert it to Kelvin. So 15, so our formula is Kelvin equals degrees Celsius, which is 15, plus 273.15 equals, use your calculator, 288.15 Kelvin. Okay? Notice there's no degrees there. Let's do this one, 75 degrees Celsius to Kelvin. Kelvin equals 75 plus 273.15 equals 348.15 Kelvin. Pretty simple. Okay, now look at this one. It's a little bit of a gotcha, but not really. With negative 15, you just put negative 15 plus 273.15. So whatever your degrees Celsius is, that's what you put in. Okay? And so that's going to give us, what is that? I had to give myself a hard one. 258.15 Kelvin. Okay? Now, that's pretty simple. But let's say we're doing some calculations and I want to make a prediction about what my measurement's going to be, I'm going to need to take my Kelvin calculation and turn it into a degree Celsius that I can measure. So to do that, we're going to take our equation, K equals degrees Celsius plus 273.15. We're just going to plug in our numbers. So K equals degrees Celsius plus 273.15. What's K? It's 15 equals degrees Celsius plus 273.15. Here, I'm going to erase this so we can see it better. Here, I'm just going to rewrite it. So 15 equals degrees Celsius plus 273.15. We're looking for degrees Celsius, but we're adding to it. So if I'm adding to it, I've got to subtract from both sides. Okay? 273.15 minus 273.15 is 0, right? So degrees Celsius is now going to equal this, which is going to be negative 0.15 degrees Celsius. Okay? See how I did that? You just plug the numbers in, you're going to subtract from 273.15. Yes, you could go straight to this, but I'm going to tell you this can get confusing when the numbers start shifting on us. So let's follow the pattern. 572 Kelvin equals degrees Celsius plus 273.15. Subtract from both sides. That goes to 0. So degrees Celsius equals whatever that is. So that's what? 3, 299, 298.85, 5, 6, 4, 5, 6, 7, 1. Yep. There you go. But it's a positive number, right? Because this is bigger. 298.85 degrees Celsius. Plug it in your calculator. Okay. Okay, so you have a sheet where you're going to do some basic conversions of basic temperature, and you're going to need to do that. When you finish that, you're going to look at the next video, which is going to be on pressure.